All right. So, what we've done now is gotten familiar with the machinery, right? We know how to build truth tables. We know how to build a complete truth table. And the obvious follow-up question should be like, why the fuck do we want to do this, right? What good does this do? And we've already gestured at this a little bit when we talked about this table, right? I just went back a slide. And we talked about how this table shows that this TFL sentence turns out to be a necessary truth, because there's no way to make it false. So this is already starting to see why we'd be interested in this table method. The tables are going to give us ways to characterize various, what we'll call, semantic concepts. So the rest of the time here, I'm just going to talk to you about these semantic concepts, what they are, and how we use the tables to check for them. Because this is the sort of thing that we really want this machinery to do. So here's the first pair of semantic notions we'll define. We'll say that a sentence of TFL is a tautology if and only if it's true on every valuation. So a sentence of TFL is a tautology if and only if it's true in every valuation. And I'll also flag something up before we go on. Every definition we're going to give, all the semantic notions, are going to be characterized in terms of this. That's why I said this concept is, in some sense, the most important notion that I was going to give you today. Everything about our machinery is going to be defined in terms of valuations, that is, assignments of truth values to atoms. So, a tautology is a TFL sentence true in every valuation. Now, what notion does this look a lot like? Mentioned it just a second ago. This is a necessary truth. This is our TFL version, if you like, of what a necessary truth is. In some sense, what we're capturing here with the notion of a tautology is a sentence that's a necessary truth purely in virtue of its structure. So, that's the definition of a tautology. The flip side, we can say that a TFL sentence A is a contradiction if and only if it's false on every valuation. And we all know what notion this is kind of mapping, right? This is the TFL-centric notion of a necessary falsehood. It's a sentence that is always false, purely in virtue of its structure. We're not going to have a definition, but we can also very easily understand what would be the TFL equivalent of a contingency. So, right, a tautology is a TFL sentence that's true on every valuation. A contradiction is a TFL sentence that's false on every valuation. So what's a TFL contingency? What's it going to look like? Yeah, we've got to be careful about phrasing, but yes, there'll be some valuations where it's true and some valuations where it's false. Now again, this is just mapping all of this, the intuitive notions we defined in lecture 1, and we talked about that first week. We've cashed it out now in terms of valuations, in terms of assignments of truth values to atoms and our big table machinery. So, we can define a notion of tautology and a contradiction. What else can we do? Well, we can talk about two sentences being tautologically equivalent. And we'll say that two sentences A and B are tautologically equivalent if and only if they have the same truth value on every valuation. Now, the important thing here is the emphasis on the every valuation. So how do we cash this out in terms of our tables? Well, when we think about tables, If two sentences match on every row of their complete truth table, and by match what I mean is the column under their main operator exactly matches, then they're going to be tautologically equivalent. If there's even a single valuation where they differ in truth value, then we know they are not equivalent. So we're going to test this using our tables. We'll build a single table that includes both sentences. And then we'll look to see, is there any row where the tables differ in truth value? If there's even a single row, not equivalent. If every single row they agree in truth value, that is, the column under their main operators has the same ranges of T's and F's, they're going to be equivalent. I'll give you an example. Let's take our two ways to define or symbolize neither nor. So what we can do if we want to look at multiple sentences, right? We write them all next to each other. We extract all the atoms from both sentences, generate a matrix. I've gone ahead and done that. Now, what would be our next step if we're going to build a complete truth table? What would we do next if we're going to build a complete table? Yeah, go ahead. Yeah, we're going to copy paste, right? Sorry, yeah, that's what you're saying, right? We copy paste. We take the column under P, we paste it under every column, every instance of P. We take the column under Q, we paste it under every instance of Q. Cool. And then next, what would we do? Again, what we do, we look to see what connectives are attached directly to atoms. What connectives are attached directly to atoms? In this case, we've got three, right? We've got our disjunction, and we've got the two negations over here. So we fill out those columns, right? So let's take this negation. Where's it looking for its input values? You got it, right? It's looking at the Q, and it does the flipping, so it gives us the opposite truth value. What's next? What's the next one we can do? Yeah, we could do the other negation, right? Where's it looking? Looking at the P, right? It's looking at the P. So it takes the P, gives you the opposite. Now we have some choices here. We can go ahead and close off the sentence over there, or we can go to our disjunction. Let's go ahead and close this sentence. We're looking at our conjunction here. Where is the input values coming from? Which columns is it looking at? Where the input values coming from here? The two negations, right? It's going to take the two negations. And so how do we fill out the column under the conjunction here? All false except for the last one. Hey! It's only true if both of them let us down. Cool. Okay. Now, of course, that's one of the two sentences down, so let's jump to the other one. Where are we going to go? What's our next column to fill in? Mentioned it a second ago. The disjunction, right? It's the remaining disjunction. And where's it looking? P and Q, right? It's looking at the atoms on either side. Right? And what's my column look like here? How do I fill out the column? Sorry, I'm being real slow because I'm trying to make sure we're all getting it. All true except for the last one, right? Because again, disjunction, easy to please. It just needs even one true to be true. Cool? Now what? Last thing, we go to our negation. And where is our negation looking for its input values? The disjunction we just did. right? It's going to take that column under the disjunction and it's going to flip every value. So we get false, 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 true. So now we've built a complete table looking at both of these sentences. And I will ask you, are they tautologically equivalent? Yay, nay. I'll remind you, two sentences are tautologically equivalent if and only if they have the same truth values on all valuations. Do these sentences have the same truth value on all valuations? Yes! Here's how we look. Again, we look at the columns under the main operators. The columns under the main operators have to be the exact same. If there is even a single row where those two columns differ, they are not equivalent. But if they are identical, cool. Now it's worth stressing when we're looking, right, to say they have the same truth values in all valuations. The only thing that matters here is the main logical operator. The rest of that is just means to get to whatever truth value we're putting in there. This column is the truth value of this whole sentence. And this column is the truth value of this whole sentence. The rest of it is bookkeeping to get us there. I want to emphasize that. I don't want people to say, oh, these have different, there's like a T over here and an F over here, so obviously they're different. No, that's not. The important thing to look for is the columns under the main operators. That is the only thing that matters for tautological equivalence. Okay, so should also ask, are these two sentences tautologies? They are not tautologies. Reminder, a sentence is a tautology if and only if it's true on every valuation. It's a contingency, right? Because both of these sentences, there's at least one valuation where they're false. And similarly, there's at least one valuation where they're true. They're not tautologies and they're not contradictions. This also shows you a way to use these tools to show that a sentence is not a contradiction or is not a tautology. If you can find one valuation, one row where the sentence is false, it's not a tautology. If you can find one row where the sentence is true, it is not a contradiction. And similarly, one row where they differ, they are not tautologically equivalent. So far, so good. Haven't even gotten to the big payoff, the big money, the big money. Okay. Let's talk about the top two and just ignore the bottom one for a second. We'll come back to it. The top two. We have some sentences, A1 through AN, are jointly tautologically consistent if and only if there's at least one valuation that makes them all true. What does that look a hell of a lot like? Consistency. Very good. Very good. So some sentences are jointly tautologically consistent if there's even one valuation that makes them all true. Possible to make them all true. Similarly, some sentences are jointly tautologically inconsistent if there is no such valuation. So put in terms of our tables, some sentences are going to be tautologically consistent if there's even one row, where underneath their main operators, they're true. Similarly, if there's no row where they're all true, they're inconsistent. So to go back a slide, to use our examples, are these two sentences jointly tautologically consistent? Are they jointly tautologically consistent? Is there even one valuation where they are all true? We're just looking here at our sentences, right? We're setting aside our matrix. Is there even one valuation where they're all true? Is there a row where the sentences are both true? If there is such a row, what does that mean? It means they're fucking consistent, right? If there's even a single valuation, a single row, where the sentences are all true, that they are jointly tautologically consistent. Which valuation is it? It's the very bottom row, right? The very bottom row. This is why they capture neither nor, right? So importantly, doesn't matter if there's a bunch of rows where they're both false. All that matters is there even a single one where they're all true. That's what it means to be jointly tautologically consistent. It's possible to turn them all on. Make them all true together. Again, joint tautological consistency, there's at least one valuation where they're all true. Joint tautological inconsistency, there ain't no valuation where they're all true. We're going to do some exercises with these during the homework, but it's useful to hear them. Now, the big money. In order to get to the big money, we got to talk about an intermediate notion. Please. Good. So, the thing to remember here is that the truth value of the sentence is whatever is underneath the main operator. So, in this valuation, let's take our top valuation, this row. What is the truth value of this sentence? If we look, the top valuation, right? The row going across, what we do, we look at the column under its main operator, and that will tell us what the truth value of that sentence is on that valuation. So, what is it? It's false, because that's the value it has. Same thing over here, right? We look at its main operator, and we see, hey, on this valuation, it's false. And the second one, same thing, they're both false. Third one, they're both false. Again, the important thing, when we're asking about the truth value of a complex sentence on a valuation, what we do is we figure out what does it say under its main logical operator. That tells you if the sentence is true or false. That's also the only one that matters for tautological equivalence, only one that matters for joint tautological consistency or inconsistency. All the rest is bookkeeping to get us there. In some ways, this and this, those are the only columns that matter. The rest are just ways to fill out. Like make sure that we get the right truth values there. Okay. So, to get to the big money, we got to go through something kind of weird. And the way we're going to go through is we're first going to define a notion called tautological entailment. That is the bottom one here. We will say that some sentences, A1 through AN, tautologically entail some sentence C, if and only if there's no valuation of the atomic sentences that makes A1 through AN true and C false. I'll say that again. A1 through AN tautologically entails C if and only if there's no valuation that makes A1 through AN true and C false. Now, what does that sound like? Very much like validity. This is going to be the way that we get to validity. We'll come to that. Hang on. So, again, the important thing here, tautological equivalence is a relation defined in terms of valuations. Now, we have a symbol to express it. We're going to use this double turnstile. The double turnstile is a way for us to say tautological entails. So if I want to say that A1 through AN tautologically entails C, I can write it like this. The stuff to the left going to be basically like our premises, and the stuff to the right is our conclusion. This says, if it's true, this says there's no valuation that makes these sentences true and that sentence false. Now, the important thing is this is different than validity. Because remember, validity was defined purely in terms of possibility. But what is tautological entailment defined in terms of? What's the key concept for tautological entailment? It's not possibility, valuations. Valuations are what's doing all of the job here. Now, some things about the double turnstile. It's not a symbol of TFL. It's a symbol we use in English. We can talk about the relationship certain TFL sentences stand into each other. But again, this holds if and only if there's no valuation that makes the things on the left true and the one on the right false. So, why do we care about tautological entailment? Well, once we have the double turnstile, we can say a few funny things. We can write the double turnstile with nothing to the left and a sentence to the right. And this is a shorthand way for us to say that C is a tautology. It doesn't even need anything to be true. Similarly, we can write a sentence and the double turnstile with nothing to the right, and it's a shorthand way for us to say this is a contradiction. Because you can put anything over here. Remember, my two ways to make an argument valid on the cheap. And the last little cool thing here is our tautological entailment relation lines up with a very interesting TFL sentence. Basically, if we have A1 through AN as the antecedent to a conditional, and C is the consequent, the entailment relation holds if and only if that conditional is a tautology. Conditional always is true. Why? Well, because that entailment means there's no way to make the first part true and the second part false. And remember, the only time a conditional is false is if the antecedent's true and the consequent is false. Okay. But all of this is dancing around the big money. Here's the big money. Again, I've defined tautological entailment. We had it a second ago. It sure does look like validity. Sure does look like validity. So what's the connection? Here's the connection. If A1 through AN tautologically entails C, then the corresponding argument where we take A1 through AN as premises and we take C as the conclusion, and this little 3 dots is just a way to say therefore, to indicate that C is the conclusion, then that argument's going to be valid. Put another way, tautological entailment entails validity. It's not the only way to get validity though, because remember, we've talked about you might be valid purely in virtue of meaning. But importantly, we know if tautological entailment holds, then the argument's valid. And this is our first big payoff. Because what this means is that the tables we just talked about give us a way to test an argument for validity. And we test the argument for validity by seeing if tautological entailment holds or not. Effectively, what we're going to do is we're going to take a natural language argument. Could be in any language you want. We're then going to symbolize it into TFL. And we're then going to use truth tables to determine whether the premises tautologically entail the conclusion or not. If they do, we know we've got something good. If they don't, then we know at least that the argument is not going to be valid in virtue of its form. We've got very good reasons to think that this is a shitty argument. Not guaranteed, but pretty good. So, what we've got now with truth tables is our sledgehammer. If you know how to do truth tables, about 90% of the kinds of arguments and reasoning that you will run into, you will be able to deal with. This is a beautiful and powerful tool. Sure. Oh, yeah, this one. So, here's the trick. Suppose C is a contradiction. Then it's going to be effectively jointly inconsistent any sentence, even itself. As we know from the very first lecture, if you have jointly inconsistent premises, you can plug in anything you want as the conclusion. The argument is going to be valid. That's why we can leave this blank, because it doesn't even matter what follows. Everything does. It's a kind of shorthand way for us to just be like, yeah, this is not a good premise. You don't really want to believe this. So again, our big payoff is that now, if we can build tables, if we can follow the method that we've talked about today, this mechanical table building process, then we now have a beautiful tool to evaluate arguments. Not just that, but also to see if a sentence is a necessary truth, to see if a sentence is a necessary falsehood, to see if it's possible to make some sentences true all at the same time or not. And to also see if some sentences are equivalent. That's pretty fucking awesome. And all we got to do is play around with something that looks a little bit like Excel. That's lovely. Take that any day of the week. So, again, this means we've got a beautiful tool. And we also have a tool for testing for invalidity. If you want to show an argument's invalid, it's real easy. You just give me a valuation, a row on the table, where the premises are true and the conclusion's false. And we can prove it. That's what the table does. So, I won't bother talking about shortcuts and partial tables. You can read the textbook here. Basically, shortcuts and partial tables are, much as the name suggests, a way to kind of shorten down doing a full table. Let me stress, I will never ask you a question on the exam that requires partial or short tables. Always an option if you want to do it. We'll talk a little bit about it in the tutorials, and you can read it in the textbook, but it's just a way to strip things back. I've also written the exam so that you have plenty of time if you do the full tables for every question about them, right? So, if you can do what we've talked about so far, money. Okay. But, before we wrap up, last thing. You guys learned a fucking language in 3 weeks. How cool is that? Not even really 3. We've only been talking about it for 2 weeks. So, you guys learned TFL. Awesome. Now we get to do the real fun stuff. Well, not even the real fun stuff. The first step in the fun stuff. So, note that what we said, the sledgehammer, what we talked about so far, incredibly powerful. And it does a lot of good stuff. But there's still a lot of other things that we might want to do with our formal system. What we're going to do next week, and in fact, from next week up until the midterm, is we're going to work on our second formal language. And our second formal language is first order logic. And I would suggest, please do the reading before next lecture. It will make life a lot easier. Now, the beauty of everything that we've learned is going to feed into our next formal language. Everything that we've talked about works in FOL. But FOL is more grammatically complex. So we have to have that foundation. But again, nicely done. We've learned a language. Very well done. Take care of yourselves, guys. Hopefully see you in the tutorials. See you soon.